But when we are in grade 8, together with all the terminologies that we've learned, one of the most important aspects with regards to seeing brackets and working with multiplication is something called the distributive law. Now, the distributive law is something that we discussed in term 1 when we had to show the use of the distributive law in breaking down a certain number. I'm going to use 10 and saying, okay, great, 10 is going to be the result of 2 times something plus something. So that something plus something needs to add up to a sum of 5. So I could write in this bracket 1 plus 4, any combination, but what I saw was that it would become 2 times 1 plus 2 times 4. Now, what I did do is I tried to link the aspect of distributive law with something that is familiar to us. It would be, for example, a mom that is distributing sweets among her children and their friends. So we think about mom gives her a sweet, mom gives him a sweet, mom gives her a sweet. But the basic thing that we see here is the use of this arrow, distribution. And that's the connection I need you to make. So this is going to help because you are going to work more accurately when you use this arrow to help you apply simplifying. Within the technique of simplifying, distribution of 3 into the bracket is part of this technique, and specifically it's called the distributive law because the big concern here is to make sure that 3 is multiplied with x, there's my bracket, my arrow, and the 2. Because what happens now is students only focus on this and then they forget about the second term. So to be very correct, accurate, we have to let 3 times x become 3x and then go back and let 3 times 2 become plus 6. So how do I know when I have to do this? Number 1, when you see a bracket. Number 2, you need as many terms in your answer as what was given in the bracket. And that's what we learned in the beginning of this chapter. We have 2 terms in the bracket, therefore this has to be a binomial. Therefore the answer has to be a binomial. So this is so important so that we in the future can apply this technique in our equations, which will be our next chapter. So I've taken this simplifying section from the Mind Action series. It's our chapter revision part. So this section D has many of these type of distributive law sums, and that's why I want to focus on them. Right, so I'm going to do a couple just so that we are on the right page, right? So let's do number 2, minus 4, and now I have a bracket x minus 2. Okay, so what we see now is we have a negative 4, and that negative 4 needs to be distributed into that bracket. Within the bracket, I have 2 terms. So let's think about it. How many terms do you think we'll have in the answer? And as we've discussed, I see 2 terms, therefore I should have a binomial in my answer. So as you work towards your simplifying, as you work towards the final answer, use your arrow. But now we will have to make sure, do we know our laws or signs? And that's something we'll have to add in. So let's quickly check that. A minus times a positive becomes a minus. A minus times a minus becomes a positive. So let's do our little bracket and see what our result is. A negative times a positive becomes a negative. 4 times 1x becomes 4x. Back to my negative 4. Back to this negative 4, I'm not done because I have not yet manipulated the minus 2. A minus times a minus becomes a positive. And that 4 times 2 becomes 8. And that's my answer. I will leave it as it is because these are not like terms. They're unlike terms, and therefore I will not be adding them. So if we do this correctly, we'll always see those aspects that we're running through, that little checklist that I spoke about so often last week, is that we look at the sign, we look at the coefficient, we look at the variable, and then we look at our exponent. And if you can check these 4 things, you will always work accurately. Because as we did here, we checked the sign, then we checked the coefficient, and then we checked the variable, and in this case, the exponent remains 1. So let's look at another one. Number 3, a bracket 3a minus 2b. Right, let's use our arrow. A times 3a is a positive times a positive. 1a times 3a, if I look at the coefficient, 1 times 3 is 3. A times a becomes a squared. Back to my 1a. And I have to now say 1a times a negative becomes a negative. 1 times 2, and a times b just becomes ab. So let's check it quickly. We have 1a times 3a becomes positive 3a squared. 1a times minus 2b becomes a minus 2ab. So we don't add another sign for this term. We don't add another 2a plus something. We don't do that. So we want to work effectively in terms of accurately, and we want to also work with an understanding of where I started to where I end. Right. Now let's look at something that looks a little bit different. Let's look at number 5. Number 5 shows us we have a bracket 3 plus 4, a bracket x minus 3. Now what we've learned in our chapter so far is that when we may simplify, we are allowed to simplify. Let's go with that simplifying technique before we do anything else. And that's when we work with like terms. And in this case, I do have this bracket 3 plus 4, which may be simplified. Mathematically, I can go ahead and I'll see, okay, great, that's 7. There's nothing stopping me there. So that still remains in front of my bracket so that I can apply the distributive law. And therefore, 7 times x is 7x. 7 times negative 3 is negative 21. Just so that you can see that it might look different. Now, let's look at one that looks like this. Number 7. So this is what we will experience when we look at our next chapter, when we also solve for x. And these would be our intermediate steps when solving for x. That's why I will continue to incorporate the aspects from this chapter within our next chapter. And In this way, we can also make sure that we're all on the right track. So let's quickly see. Okay, can I simplify anything here? Okay, that's a 3x, and that's a 5x, so great. But in this bracket, 2x minus 1, okay, leave that bracket, but hey, let's look here, okay, great. What my rule is that I may add apples to apples, but can I add a banana to an apple? No, there's no way I can grow a banana joint with an apple. I want to add apples, and that's my like term. Add it to my like term, which gives me 8x, and write it directly next to that bracket. Right, let's apply our distributive law. Here we need to watch out though. If we use our checklist that we have here, sign, coefficient, variable, and exponent. Let's quickly just add that in there. We always want to keep that checklist handy because that's like your best tool to always check that you're doing the right thing. Copy and paste it, add it in there, use it, work effectively, not forget. Great, sign, coefficient, variable, exponent. Let's go ahead. 8x times 2x. Great, let's do the sign first. My sign is positive. Super. Little positive, I don't have to write it, but I know, great, it's positive. 8 times 2, that's the coefficient. 8 times 2, 16. Variable, x times x. Now, x times x becomes x squared. But x plus x becomes 2x. Let's just remember that. So here I have x times x, so I have 16x squared. Back to the 8x, I'm not done yet, multiplied by the negative 1. Positive times a negative becomes a negative. 8 times 1 becomes 8. And x times 1 is still x. It's one term binomial. Okay, let's look at another one that might be scary. So if we look at, let's see here, make it another color. Let's look at number 9. So number 9 shows we have negative 2y, negative y, bracket, open bracket, 2y minus 3. And can we simplify something here? This remains, 2y minus 3 remains as it is. But let's check this one quickly. Very careful here. This is minus 2y minus 1y. Okay, now instead of adding a positive and a positive, I am just adding negative 2 with a negative 1. So I am actually becoming very negative because I've added a negative 1. Okay, which means adding a negative 1 makes you colder. According to our temperature line, we're moving into the negative field to the left. So this leaves me with the negative 3y bracket 2y minus 3. I keep this bracket right here next to the result of minus 2y minus 1y. There is no multiplying in my first bracket. There is no product happening here, purely simplifying by adding the negative together. But now I get to my next step, and now I will multiply because now I have one term directly next to that bracket, and that gives me the clue that multiplication is needed. Negative times a positive becomes a negative. Coefficient 3 times 2 becomes 6. Variable y times y becomes y. Exponent to the power of 2. Look how nicely those tips help us work effectively, always. Let's continue. We are not finished because minus 3y times the bracket 2y minus 3 does not give me minus 6y squared. I need to still finish up. Go back to my minus 3y multiplied by the negative 3. A negative times the negative becomes a positive. 3 times 3 becomes 9. Y times that 3 is already sorted out, so there's no other variable to complicate things here. Simply becomes 9y. And I leave my answer as it is because this cannot be simplified. Minus 6y squared plus 9y is my final answer. So we see there are various ways in which we can write our answers, but those ways all depend on what's been given to us. It's such an important aspect in maths that we must always understand what do we need to do first. Okay, right. So if we look at another example, perhaps we can see sometimes we have a little bit of shuffling around of things and we don't need to worry about it. We can make it look like something we've seen before. So let me just zoom in there quickly and find it. Okay, I'm going to pay attention to number 14 and I'm going to use number 14 as our last example for today. Then we can all practice some more. Right, what do I have there? So when we look at the rules that we've learned in maths, we spoke about a commutative law and an associative law in our first term. Term 1, we dealt with those laws because those laws are things that we will see appear within our work forward. So when we have the commutative law, let's just remind ourselves, we are commuting. So it's like a train with carriages, but that train still results in the same product or sum. The final destination of that train is still the same destination. Commutative law tells me that I may add A and B and C and I will still get the same sum, or I may multiply and I will still get the same product. Therefore, the commutative law tells me that if I have minus something, I'm going to call this A and B. I may also say minus B times A. Therefore, let's quickly see. We have a negative here. We have a bracket with a trinomial here. And then we have a bracket with a monomial here. Product is product. So don't stress about it. But let's make it easier on the eye because our eye does not like to take things from there, multiply it with there, and then write it down here. That's labor intensive. Let's make it a little bit better and sort it out first. I'm going to keep that negative. That negative needs to stay here. But what I'm going to do is I'm going to put my monomial first. And my monomial stays as it is. It's a negative 2x. And then I'm going to scoot the trinomial next to the monomial. And then it's going to look like something a tad simpler than what it looked like before. But what I may do here, what I may do in this case is I may sort this out. Why am I allowed to multiply this sign into this bracket? Because the power of this bracket is still 1. The power is not being raised. Therefore, we may go forward. And that gives me a positive 2x. Now that positive 2x will be multiplied into my trinomial. And now let's fire away, but we've got our little checklist. Use our checklist. Positive times a positive becomes a positive. 2 times 1 becomes 2. X times x to the power of 2. X to the power of 1 times x to the power of 2 becomes x to the power of 3. Our laws of exponents, that's what's helping us here. Exponents, laws of exponents tell us that when we are multiplying the same base, we have to add the exponent. Great, next one. Plus, okay, so we've done this one. A plus times a minus is a minus. A 2 times 5 is 10, and a x to the power of 1 times x to the power of 1 becomes x to the power of 2. Not done yet. Get back to my 2x. There is a minus 6 left. A positive times a minus is a minus. A 2 times 6 is 12, and an x times that just simply becomes minus 12x. And then let's look at our final answer. Can I add anything together here? No ways, because they're all unlike terms, so I will leave it as it is, unlike terms. So where do my marks lie? My marks lie in my application of my distributive law. My marks lie in treating my exponential laws with care and treating my signs with care.